Hey guys, this is Mr. Lowry. I'm just wanted to walk you through this Unit 2 Quiz 3 practice. This is going to be pretty similar to the quiz that you're going to take on Friday, and there's several steps to some of these problems in terms of factoring. So what we talked about in class today and in our previous class is a general procedure for factoring. So I have my general factoring procedure written out here. This is also in this assignment, in the description of this assignment, where I usually put all the notes and stuff from class. This is in there as well. If you were here in class, this is already in your notebook. If you weren't in class, then you can copy this into your notebook or print it out if you want to and include it in your notebook. But basically we have a three-step process here, and all of our different factoring techniques are included on this general factoring procedure. So step one is always find the greatest common factor and take it out. Now technically there always is a greatest common factor, but it could be one, in which case that's not super interesting. So you may not find a greatest common factor other than one, and that's okay, but a lot of them will have a greatest common factor. So find the greatest common factor and take it out if there is one. Okay, now the next step, it depends on what you're left with. So you want to determine the number of terms left, and there's different scenarios, right? So A is the scenarios that you might have if you have two terms or a binomial. B is the scenario that you might have if you have three terms or a trinomial. And then if you have four terms, you're going to factor by grouping. So when you do step two, we're not going to do every single one of these steps. We're going to actually find a specific method and use it. So we're going to kind of go through these as possibilities. Is it two terms? Yes or no? Is it three terms? Yes or no? Is it four terms? Yes or no? If the answer is yes to that question, then you figure out which one of those strategies you're going to use. And then step three is to just go back and check for anything else that is going to factor. So sometimes you have whenever you do step two, you end up with something that will factor even more. So let's take a look at some of these problems here, and I'm going to go through all of these here for you. So the first one, we have 125x to the fourth minus 8x. So let me zoom in a little bit here, if I can. There we go. The first thing we want to do is find the greatest common factor. Now there's not a number besides 1 that goes into 125 and 8, but x goes into both of these, so we can actually factor out of x. So the greatest common factor is x. We pull that out and we're left with 125 x to the third minus 8. Okay. Now we just did step one, factor the GCF, okay? Step two says determine the number of terms left. So we have two terms left here, and so we're going to look at our two-term possibilities. We're going to see, do we have a difference of squares, do we have a difference of cubes, or do we have a sum of cubes? So when I look at this, I see that cube there, but also, hopefully we're noticing by now that 8 is 2 cubed and 125 is 5 cubed. So you may want to create a list of perfect cube numbers and keep those handy so that you can recognize these when you see them. Okay, so we definitely need to factor this difference of cubes here, so we're going to use this template. But before we use it, we have to make sure we write our difference of cubes as something to the third power and something to the third power with a minus in the middle. So right now, it doesn't look exactly like that. It's close. And so what we're going to do is we're going to, off to the side, take our binomial. We're going to write it as everything to a power of 3. Okay. And then we can keep going until we have basically an a to the third and a b to the third, right? So this is our a, and this is our b. And we're going to use 5x and 2 instead of a and b, and we're going to use this template. So this template says I need a minus b, and then a squared plus ab plus b squared. Okay, so if my a is 5x and my b is 2, that's going to leave me with 5x minus 2, that's the a minus b part. And then I'm going to have a squared, which would be 5x squared in this case. Sorry, extra parenthesis there that I don't need. (5x squared) in parentheses, right? 5x in parentheses squared. And then we're going to have plus a times b, which would be 5x times 2. And then plus b squared, which would be 2 squared in this case. So we're just using this difference of cubes template. We just got to figure out what the a and the b are and by writing it like this. And then we can just substitute for a and for b. So that's what we get here. So we got 5x minus 2. Now when we have 5x in parentheses and that's being squared, we're going to square the 5 and square the x. So that's going to give us a 25 times x squared. Okay, 5x times 2 is 10x. Okay, and then 2 squared is 4. So that's what my difference of cubes binomial is going to factor to. We can't forget, though, when we moved off to the side, we kind of ignored this x for a minute, but that x is still part of our final answer, so we don't want to forget that x, that greatest common factor that pulled out. That's part of the answer as well. Okay, so we kind of skipped over step 3. Let me go back and talk about step 3 really quick. Step 3 was to check for any factors that can be factored further. Okay, well, this guy can't be factored any further. And this guy's a binomial, but it's not a difference of squares or a sum of squares or a difference of, it's not a difference of squares or a sum of cubes or a difference of cubes. So this can't factor. Okay, let me give you one other hint. Whenever you use a difference of squares, a difference of cubes or a sum of cubes, the template, the formula, this trinomial that comes out is always going to be prime. So on your note sheet, if you haven't already, what I would do is I would just make a note that that thing right there is a prime trinomial. In other words, it doesn't factor any further. So don't try to factor these guys because they won't factor. Now we are going to get other trinomials that we can factor, but whenever we use these two templates, we always get a binomial times a trinomial, and that trinomial that comes out will not be factorable. So don't try that. That's why I didn't really worry about it here. I knew that wasn't factorable, this I know is prime. So step 3 is to go back and check to see if anything is factorable further, and it's not, and so that's why I put my box around it. All right, in number 2 here, we need to find the greatest common factor again. So step 1 is always the same, find the greatest common factor. In this case, you got a u and a u, and you'll notice that we have a 4 and a 500. Now over here, we didn't have common factors with 125 and 8, but 4 and 500 do have a common factor because 4 actually goes into 500. So if you factor out the greatest common factor is 4u, not just u, it's 4 and u, and when you pull that out, you get u to the third plus 125. Okay? Now, that's step 1. Okay, go back to our general factoring procedures, and we're like, okay, check step 1, check. Now we determine the number of terms left. Well, we've got 2 terms here. Okay, so we take a look. Is it a difference of squares? It is a difference of cubes, or it is a sum of cubes. When we look over here, it looks like a sum of cubes because we got u to the third. We also know that 125 is 5 to the third power. Okay, so what we need to do then is we need to write this as 2 things to the third power to help us factor it. So the 4u is going to come along for the ride. I'm just going to draw an arrow down to the bottom because I don't want to forget that in my final answer. But I'm going to focus my attention on just the sum of cubes trinomial over here. So if I want to rewrite this, this is u to the third plus 5 to the third. Okay, so this guy becomes my a, and this guy becomes my b. When I'm using my template, my sum of cubes template that we came up with, this guy, I need an a and I need a b. So I need to write it as something cubed plus something cubed. I need it to look like this so I can figure out what my a piece and my b piece are, and then I can use the rest of the template. Okay, so in this case, I want to use this template, but my pieces are u and 5 instead of a and b. So what I'm going to have here is going to have u plus 5. Okay. Then I'm going to have u squared plus, minus is the next thing, minus, and it's going to be u times 5. Now u times 5 we write as 5u. So we're going to leave it as that. And then the next thing we have is b squared. In this case, that's going to be 5 squared, because 5 is our b piece. And since 5 squared is 25, I'll just write it 25. Okay, so that is how my sum of cubes is going to factor. So that's almost my full answer. The problem is we don't want to forget our greatest common factor that came out. So I have a 4u, I have a u plus 5, and then I have a u squared minus 5u plus 25. Okay, so we did step 1, greatest common factor. Step 2, we noticed that we had a sum of cubes, and we factored that sum of cubes. Step 3 then would be to check to see if anything else is factorable, right? Well, the greatest common factor isn't going to factor anymore. We don't need to factor that anymore. This is a binomial, but it's not a difference of squares or a sum of squares, or a difference of squares or a difference of cubes or a sum of cubes. And this one we know is prime. I told you that whenever we do the difference of cubes or the sum of cubes formula, this trinomial that comes out is going to be prime. So don't worry about trying to factor that guy, because it's not going to factor. Okay. All right. So notice how 1 and 2 are pretty similar. One of them's a difference of cubes, the other one's a sum of cubes, and there's a couple steps to those because you got to take out the greatest common factor. The next two are also similar. They're not exactly the same, and there's something kind of unique about number 4 that we'll see in a second. But let's go through our list, right? So the first thing we're always going to do is look for our greatest common factor. Okay. In this case, if you spend some time looking, you'll notice that they're all definitely even, so they're all divisible by 2, and that's actually the biggest number that we can take out of all of those terms. In terms of the letter, we have x's in each one of them, and since my smallest power of x is just x to the 1, that's the most x's I can take out. Okay, when I take that out, I'm going to have 9x squared plus, this is going to be 74, I believe. Let me just check that on my calculator. I might have messed up there, but let me double check. 1. Okay, cool, got that right. And then 32 divided by 2 is 16, and we took the x out. Okay, so step 1, again, always the same. Factor out the greatest common factor. Okay. Now we look, step 2 is to see what's left, right? What do we have left over? So we look at our list and we're like, okay, step 2, we don't have 2 terms, so we're not going to use any of these strategies. We're just going to skip right over those and we're going to go to the next one, 3 terms. So since we don't have 4 terms or 2 terms, this is where we're focusing our attention on. And we got to figure out, okay, what kind of 3-term polynomial do we have? Is it the kind where there's no coefficient in front of x, or there's like an invisible 1? Is it the kind where there's a number besides 1 in front of x squared? Or is it maybe a quadratic in nature that we saw earlier this week? In this case, we have something of the form ax squared plus bx plus c. Notice that there's a coefficient on the x squared that we can't just factor out. So we're going to have to use our AC grouping strategies. Our 2 strategies here are guess and check or AC grouping. AC grouping is kind of tricky, so if you're having trouble with the AC grouping method, I would go back to that assignment and practice some more. Open up that assignment in Canvas if you want to. Go back through and look at some of those videos and get that technique down, because that can be a little bit tricky. Let me walk you through it though. We're going to take this 2x here and we're just going to draw an arrow. We're going to kind of ignore that for a minute. Okay? What we really want to do is we want to focus on this trinomial right here. And the AC grouping method says to multiply a times c. That's the coefficient of the x squared times the constant. So 9 times 16. In this case, 9 times 16 gives me 144. Okay? What I'm looking for is factors of 144 that combine to give me 74. So I multiplied 9 times 16 and get that guy. and I want to find factors of that guy that combine to give me this guy. Okay, so the factors of 144, if we want to kind of make a list, we got 1 times 144, and then we got 2 times 72, and you can pretty much stop there because you're like, aha, 2 times 72, those are the numbers I'm looking for. Those are the ones that combine to 74. Okay, so what we need is a 2 and a 74. Okay, now what do we do with those numbers? In the AC grouping method, we take those two guys and we split the middle term. Okay, so remember the 2x we're ignoring for a second. I'm just looking at this guy. But I'm going to rewrite it as 9x squared. And this 74x I'm going to split, basically uncombine like terms. So I have two terms here. And we can put these in either order. It actually doesn't matter. I think that it's going to be better if we put the 72 first. I'm sorry, I'm going back here. You guys were probably screaming at the screen and saying, hey, that's a 72. Yeah, 2 times 72 is 144, and 2 plus 72 is 74. So we want a 72, 2 and 72. So again, I can put the 2 here if I want, or the 72. It doesn't really matter. I think it'll look a little bit nicer, or it'll be a little more obvious to factor if we put the 72x here and then the 2x here. So I forced my trinomial to be a 4-term polynomial. I made it happen. I split it up. I split up that middle term. Why do we want to do that? Well, the whole goal here is to factor by grouping, which is why it's called the AC grouping method. So here's AC, right? We find that number. And then we use these two numbers to group. So that's why it's AC grouping. Now these guys have a common factor of 9 and x. So if I factor out a 9x, I'm going to be left with x squared plus 8. Oh, sorry, not x squared plus 8. X plus 8, excuse me. And then over here, these have a common factor of 2. So if I pull out a 2, I'm going to be left with x plus 8. Okay, notice common binomials, right? That's great news because we want to be able to factor those out. In fact, if we're factoring by AC grouping or just grouping in general, we expect those guys to have a common binomial. So if we didn't get a common binomial, we might be a little bit worried at this point. But since we got an x plus 8 and x plus 8, we're good. So we're going to factor out the x plus 8. Okay, and what's going to be left is the 9x and the 2. So if we pull these guys out to the front, what's left is the 9x and the 2. So we got 9x plus 2. Okay, and we have to go back and remember this arrow here was reminding us that we took out a greatest common factor of 2x at the beginning. So we did step 1, pull out the greatest common factor. Step 2 was recognizing this was a trinomial and then using our trinomial factoring technique, which was AC grouping, to factor the trinomial. Okay, now step 3 would be to check to see if anything else can be factored. So we already got our greatest common factor out here. We got this binomial, but that's not a difference of squares or a difference of cubes or a sum of cubes, and neither is this. So neither of these two binomials will factor any further. The greatest common factor is already out there. So there we go. That's going to be the answer. So just to kind of run through our list again, we factored out the greatest common factor. That was 2x. We determined that we had 3 terms, so we skipped over all this stuff. We didn't care about this. We didn't care about 4 terms. We're focusing on 3 terms. And since it looked like this, we used AC grouping to make sure that we got that factored. Once we had that factored, we went to step 3, which was check to see if any of our new factors are factorable, and they weren't, so we knew we were done. Okay, number 4. This one's going to be set up kind of similar, but there's actually something kind of funky that happens. First, we want to recognize that there's a greatest common factor of 5x here. And just so I have enough room, because this might take some space, I'm going to factor out the greatest common factor up here. Okay, so 5x comes out, and we're going to be left with 7x squared minus 3x minus 8. Okay, so step 1, check. Take out the greatest common factor. Yep, we sure did that. So step 1, we can check off our list. Okay, step 2, determine the number of terms. Well, again, we have a trinomial, and again, it's one of these guys. Looks like this. So we can try AC grouping again, or we could do guess and check if we want. I think the AC grouping is a little bit more straightforward. So let's take a look at that. Okay, this is the trinomial we're trying to factor. We're going to have that 5x out front at the bottom, so let's kind of move that out from our polynomial here and just focus on the trinomial that's left over. So I have 7x squared minus 3x minus 8. So the AC grouping method tells me I need to multiply 7 times negative 8, and that's going to give me negative 56. And then I want to find factors of negative 56 that combine to give me a negative 3. Okay? Now let's think about the signs for a minute to make our work a little bit easier, narrow down the possibilities. If these two numbers are multiplying to a negative number, that means they have to be opposite signs. If they were both negative, they would multiply to a positive. If they were both positive, they'd multiply to a positive. So I have to have a negative and a positive. Also, since they combine to a negative number, I know that the negative one's got to be the bigger one. So let me list out the factors of 56. So 1 and 56, right? 2 and 28. Okay, 3 doesn't go in, but 4 does. It's 4 times 14. And 5 doesn't go in, and neither does 6, but 7 does. 7 times 8 will work. Okay. And then 8 will go in, but that's 8 times 7, and then we're starting to repeat our factors here. So we got the factor groups. We know that the negative one has to be positive. The bigger one has to be negative. So I'm going to put a comma and then make all these negative. Right. So the big ones are negative. And I'm looking for something that combines to a negative 3. So 1 combined with negative 56 is negative 55, so that's not going to work. If I combine 2 and negative 28, so like this kind of thing, these combine to negative 26, so that's not going to work either. Okay. So this is kind of what I use my box for. If I do negative 14 and 4, well, those multiply to negative 56, but they don't combine to negative 3, so it's not those guys either. And my box is starting to get messy. Let's try 7 and negative 8. If I do negative 8 and 7, those are going to multiply to negative 56, but those combine to negative 1, and so that's not the option either. So that's kind of weird, right? I look for all my factors of negative 56, and none of them will combine to give me a negative 3, and I've exhausted all my possibilities. What that means is that this guy right here is prime. In other words, it can't factor any further. If there are no factors of negative 56 that combine to give me negative 3, I can't split this term up like I did over here, and I can't factor it by grouping. So this trinomial is prime. That means it can't factor any further. But we did do some factoring. We did do a little factoring because we took out the greatest common factor, right? So we took out the greatest common factor. That was step 1. Step 2 was to check to see if this trinomial was factorable, and we tried AC grouping, and we didn't get any options. Now, if we were to try guess and check, the same thing would happen. We'd try all of our possibilities, all the combinations of 7 and 1, all the combinations of, so 7 and 1 here, and then you'd try like the factors of 8, so 8 and 1, 4 and 2, etc. And you would notice that none of them work. So whether you use guess and check or whether you use the AC grouping method, you're going to find that that trinomial just doesn't factor, and it's prime. All right. Number 5. I'll try to focus here a little bit. Okay. Once again, this first step is always find the greatest common factor. Okay. In this case, the number part is 5. 5 goes into all of those. We also got to take care of the variables, though. And if we notice that the smallest power of a is a to the third, that is the most a's that we're going to be able to take out. Okay. So We take out the 5a to the third, and we're going to be left with a to the fourth minus 11a squared plus 10. All right. So step 1 complete. Factor out the greatest common factor. All right. So we can check that off our list. Step 2 is determine the number of terms left. Now we have a trinomial, right? So 3 terms left over. And it kind of looks like this, but we have a power of 4 here and a power of 2 here. It doesn't have a coefficient in front of the x. It's actually one of these guys. Okay, it looks more like this. These are called quadratic in nature. And the quadratic in nature ones actually factor kind of like these guys factor. But there's a little extra step. So this is a process that we covered in class this week. But if you missed that, you may want to go back and look at the lesson for Monday or Tuesday, depending on which cohort you're in, because we talked about quadratic in nature and how to factor. Okay, let's take our greatest common factor, 5a to the third, and let's just put it down at the bottom, because we know that we're going to want that in our final answer. But we're going to kind of ignore it for a second, and we're going to shift our focus to this trinomial right here. Okay, so this trinomial is a quadratic in nature, and what that means is it behaves like a degree 2, even though it's not a degree 2. And the pattern that we're looking for is the degree of the first term is double the degree of the second term, and then the degree of the last term is 0, or in other words, there's no variable. So this should be double this, and this shouldn't have a variable. All right, so what we're going to do is we're going to write the related quadratic. What that means is we're going to kind of take this guy, and we're just going to write a quadratic that's like it, even though it's not exactly the same. And I'm going to use a different variable because I don't want to get my W's and my A's mixed up. Sorry, my eraser is just kind of smudging here. All right, so this is what I got. W squared minus 11W plus 10. Now this is just like a substitution. I'm just finding something that looks similar so that I can factor it, and then I'm going to use those numbers. So we're just kind of making our lives a little easier for a second. This is just kind of a substitution step. Now when we factor these and they don't have a coefficient right here, or in other words the coefficient is just an invisible 1, all we need to do is find factors of 10, factors of c, basically the last number, that combine to give me this guy. So we're looking for factors of 10 that combine to give me a negative 11. Because this is positive, these two things that multiply to this have to be the same sign, either both positive or both negative. But since they combine to a negative number, the only option is they're both negative. And if you got that, then it's probably pretty quick to get that it's negative 10 and negative 1. So this guy right here factors to W minus 10, W minus 1. But this isn't really what we're interested in. It's similar to what we're interested in, but it's not exactly what we're interested in. What we can do, though, is we can use these two numbers, and we can use those to factor this guy. All right, so what we're going to do is we're going to take this guy and we're going to factor, and we need to put an a squared and an a squared, and the numbers that we put in there are minus 10 and minus 1. So notice that minus 10, right? Minus 1, minus 1. The difference here is that this is a degree 2, and so when we factor a degree 2, we expect to have 2 degree 1s, right? When we factor a degree 4 that's quadratic in nature, what we need to have is 2 degree 2s. In other words, we take this guy and we divide it by 2, and we're like, oh, the degree that we need here is 2. It's half of this guy. Okay? Another way to think about that is the degree of the middle term will match the degree of the letter in your binomials. So there's a W in the middle, that means WW. Right here, there's an a squared in the middle, so a squared, a squared. Now we're ignoring the coefficient, we're just looking at the degree. We're like, oh, it's the degree 2 in the middle, so degree 2, degree 2. Those are going to multiply to give me that degree 4 there. All right, so this is what we got, and that was step 2. So let's run through our steps again just to double check. All right, step 1, factor out the greatest common factor, check. It was 5a to the third, we did that. Okay, then we kind of came down and we decided it's not a 2-term, it's a 3-term, and it's actually a quadratic in nature. And so we factored that guy. Okay, step 3 would be check for any factors that can be factored further. So we go back and we're like, okay, this guy looks kind of like a difference of squares, but that is not a perfect square. And this guy looks like a difference of squares, and it is because that is 1 squared. Right? 1 is 1 squared. So if you want to, you can think of it like a squared minus 1 squared, right? And we know that we need to factor a difference of squares like this with a conjugate pair. So if you have something squared minus something squared, you figure out what those two things are, and then you put a conjugate pair, a plus b, a minus b. So in this case, my a is actually a, and my b is 1. Okay, so this guy's actually going to factor to a plus 1, a minus 1, a conjugate pair. So let's put it all together. Here's the greatest common factor. That drops all the way down here. Okay, this guy is not factorable any further. It kind of looks like a difference of squares, but since 10 isn't a perfect square, we can't really factor it and get integers out of it. So we're going to put a squared minus 10. Okay, and then this guy right here actually turned into 2 other factors. So instead of a squared minus 1, I'm going to write a plus 1 and a minus 1. Okay, so we go back to step 2. We notice there's a difference of squares. We factor that difference of squares, and now we double check again. So step 3 again is, do I have anything that factors anymore? So no. We already checked these 2. Nope. Okay, that's not factorable. That's not factorable. All right, cool. There we go. All right, so here's the next one, and this is going to kind of work out pretty similar. This is also a this is going to be a quadratic in nature. So let's check this guy out. We got a common factor of definitely x. Now we have a 4 here, so my question is, does 4 go into this or this? And so I'm hoping that 4 goes into 72 and 4 goes into 320. Maybe not, but we're going to double check. So I'm going to do 72 divided by 4. Sorry, that's 18. So that works. Cool. And let's do 320 divided by 4. Awesome. So 4 goes into all of those. Cool. So that means I can take out a 4. And also I can take out an x as well, so 4x. All right, that's going to leave me with x to the 6th minus 18x to the 3rd plus 80 All right, so this is actually a quadratic in nature again, and remember that pattern is the degree of the first term is double the degree of the second term, and then there's no variable here, or in other words, this is a degree 0. So step 1, factor out the greatest common factor, check. Step 2, how many terms are left? 3. It's a trinomial. So we go through our trinomial possibilities, and one of those possibilities is it a quadratic in nature? And that's what this is. So what we can do is we can write a related quadratic. So this isn't a quadratic, but I can kind of dream, I can wish, like I can hope, can he? Right, there's my related quadratic. That I know how to factor. I'm just looking for factors of 80 that combine to give me negative 18. And since this is positive and this is negative, they got to both be negative. And it looks like it's going to be 8 and 10. Right. All right, so this guy here is not going to factor exactly the same, but it's definitely going to be similar. I'm going to have a minus 8 and a minus 10 for sure. So let's take a look at that. We got this guy that we're trying to factor. So we know we need to have a minus 8. We know we need to have a minus 10. Okay. But we're not going to put a w or an x up here. We're actually going to put an x to the third. So remember, we want half of the degree of this one. Or in other words, we want the degree of the middle one. Okay, so that's what we end up with. Now let's not forget our greatest common factor here, 4x. Okay, so step 1, greatest common factor, check. We're going to have that in our final answer. Let's not miss that. Step 2, we have a quadratic in nature that we're going to factor to x to the third minus 8 and x to the third minus 10. Now this guy here is a difference of cubes. So step 3 is to check for anything that factors further. And there is something that factors further. It's this guy right here. It's this, difference of cubes. So we want to write this as 2 things cubed. So x to the third is fine, minus 2 to the third. Okay, that's 8 is 2 to the third. And then now this is my a and this is my b. Now this guy looks like a difference of cubes too, but this isn't a perfect cube, so we're not going to have to worry about that one. Let's jump back to our template here and remind ourselves of this pattern. Okay, so if I have something cubed minus something cubed, then we're going to have like those 2 things subtracted. Anyway, I've got to figure out what my a and my b is, and then I just throw in the a and the b into this template. Okay, so I have something cubed minus something cubed. I have x cubed minus 2 cubed. So x is a and 2 is b. And I just need to rewrite my template, but instead of a and b, I'm going to use x and 2. And I'm going to do that down here, my final answer. So we're factoring this guy, right? And the first piece is going to be x minus 2. Okay, then the next piece is going to be a squared, which in this case will be x squared, right? And then I have the plus ab. In this case, my a and my b are x and 2, so it's going to be plus 2 times b. 2 times x. Okay, and then the last term is going to be b squared, which would be in this case plus 4, because 2 squared is 4. Okay, so again, I'm just following this template right here, the difference of cubes template. I determined that my a was an x and my b was a 2, and so I'm putting everywhere there's an a, I'm putting an x, and everywhere there's a b, I'm putting a 2. And then simplifying. Okay, so this guy right here becomes this and this. Remember, a difference of cubes factors to a binomial times a trinomial. But let's not forget, I still had this guy right here that I haven't taken into account. And that guy hasn't changed at all. We haven't factored that guy. Okay, so step 1, greatest common factor, pull it out, check. Step 2, we're left with a trinomial. It's a quadratic in nature, so let's factor that the way we factor a quadratic in nature. Very similar to a regular quadratic, we just have to make sure we have higher powers up here. Step 3, go back and check for anything that's factorable even more. And this guy is a difference of cubes, so we have to keep factoring that guy. So we have our original greatest common factor, that's here. We have this difference of cubes, which factored to this piece and this piece. And then we had this other binomial that's not factorable down here. And so this has actually 4 terms, or 4 factors. And there we go. Okay, 2 more. These should be a little bit faster, hopefully. All right, first step again, find the greatest common factor. In this case, we got divisible by 2, divisible by 2. They both have x's in it, so we're going to take out a 2x, which leaves me with an x to the 4th minus 16. Okay? All right, that's step 1. Step 2 is look for how many terms you have, and I have 2. So determine how many terms. There's 2 terms. Okay, so that means I'm in binomial land. Is it a difference of squares? Is it a difference of cubes? Is it a sum of cubes? Well, it doesn't look like there's a squared or a cubed, but that's definitely 4 squared. So here's a little trick that we talked about in class last week. Anytime you have an even power, you can write it as a power of 2. So we can write this as a power of 2, which means this is actually a difference of squares. So let's get rid of our greatest common factor. Let's get that off to the side. Let's not worry about that. We're going to focus on this, x to the 4th minus 16. And I can write this as x squared minus 4 squared. Kind of weird, but again, every even power can be written as a power of 2. Okay, and this obviously was 4 squared, so that's our clue, even power and perfect square, that this is a difference of squares. And so this is going to become my a, and this is going to become my b. When I look at my template here, if I have something to the second power minus something to the second power, this is the template I use. The difference here is I know that a is x squared and b is 4. So everywhere there's an a, I put an x squared, and everywhere there's a b, I put a 4. Right, because there's my a and there's my b. So what I have is x squared plus 4, and then x squared minus 4. Right, that's my conjugate pair. That is my a plus b, a minus b. Right, a plus b, x squared plus 4, x squared minus 4. Okay, so step 2 is now complete. I figured out that I had a difference of squares, and I factored it using my difference of squares template. And now we move on to step 3. And step 3 says that you got to go back and check your factors. So you got to go back and look at these and say, okay, well that's not factorable, right? That's a sum of squares, which you can't factor. But this guy is a difference of squares itself. And so we had a difference of squares inside a difference of squares. Kind of crazy. So this difference of squares will factor, and this is a little easier to factor. This is going to give me x plus 2, x minus 2. Right? This is x squared, and this is 2 squared. So this guy turns into these two. This guy's not factorable. It's we can't do a sum of squares. We can do a sum of cubes, but not a sum of squares. So I've got my original 2x. I've got my x squared plus 4, which is not factorable. And then in step 3, we determined that that was factorable. Okay, and then I guess we should go back and check to see if anything else is factorable, but those definitely aren't. And we already know that isn't, and we already know that isn't. So that's how you do that one. All right, this guy's going to be kind of similar. So let's take a look. This has a 3 in it, so hopefully this is divided by 3. 243 divided by 3. I'm hoping that that's going to work out. I'm betting it will. Okay, cool, that's 81. And they also have, they both have at least 2 x's in it. So I'm going to take out a 3x squared. Okay, and that'll leave me with x to the 4th minus 81. Okay, so step 1 is complete, right? Step 1, factor out the greatest common factor. Step 2, what's left? Well, we got a binomial. Okay, so we're going to focus our attention on the binomial stuff. And we don't see any powers of 3 in there, but we do see even powers. And 81 we know also is 9 squared. So when I look at this guy, I'm like, all right, that can be written as a power of 2. That can be written as a power of 2. So even though I don't see any like specific exponents of 2, I know that both of these actually are powers of 2. So let's get rid of my greatest common factor. Let's get that out of the way, and let's focus on this guy. So I can write x to the 4th as x squared squared. And I can write 81 as 9 squared. All right, so using my template here, my difference of squares template, I know I'm going to have a conjugate pair. In other words, the same 2 terms, but one has a plus and one has a minus. But this time, I know my a and my b basically, are going to be x squared and 9. Right? Because that's what I have squared. I have x squared squared, and I have 9 squared. So this is my a, and this is my b. And I just follow the template. The template says do a plus b and a minus b. So in this case, that'd be x squared plus 9 and x squared minus 9. All right, so that's step 2. We found ourselves a difference of squares. This is a sneaky difference of squares. All right, it doesn't look like a difference of squares because of that 4, but it is a difference of squares, and we can factor it like one. And then we go to step 3. So step 3 was go back and check any of your factors to see if they can factor further. Now this guy can't, because again, we can't do a sum of squares. We can do a sum of cubes, but a sum of squares doesn't work. We can't factor it. But this guy is another difference of squares, right? Because that's 3 squared. So this is a little bit easier to factor than this guy. Now if we really, really wanted to, we could take this guy off to the side and say, well, this is x squared minus 3 squared. And then you could say this is a and this is b. So I need an a plus b and an a minus b, and that's x plus 3. That's x minus 3. But at this point, I think we're pretty familiar with these. We've seen enough of these that I think at this point you should probably be pretty good at recognizing that and factoring that. This one, of course, is a little harder because the power of 4 kind of is tricky and throws us off. But we get x squared plus 9, right, because that guy is not factorable, so we just include it. And then this guy right here breaks down into these two factors, x plus 3 and x minus 3. Okay, so we got my greatest common factor up front. Cool. We got my binomial that's not going to factor. And then these two binomials are factored as far as they're going to go. Okay, cool. All right, so that is a lot of factoring. And that's how we use our general factoring procedure, right? There's many different strategies that we've talked about, and many different skills that we have. We just got to find a way to make a systematic procedure of going through step by step and checking everything and making sure that we're factoring as far as we can go. So we go through the process, and sometimes we have to continue and repeat through that process. But this is the procedure. This is the template. These are the steps, and you just repeat these steps as needed. So I would write this down, make sure it's in your notes because you can use this on your quiz on Friday. Your quiz is going to look, it's going to have similar problems to this. So make sure that you know each of these factoring procedures and that you can do them all step by step with many different steps. So you're definitely going to want to know difference of squares. If you're shaky on those, then probably go back to the difference of squares assignments that we've done and practice. If you're shaky on difference or sum of cubes, go back to that worksheet that we did, that assignment that we did. Open it up in Canvas, watch the videos, make sure you're good with those and comfortable with those. And we got trinomial methods, right? So AC grouping, make sure you're good on that. Make sure you can factor a quadratic in nature, and that's not scary for you. We did that this week earlier. And if you can do all those things individually, then when we put it all together, it's not too big of a deal. It takes several steps, and sometimes it's time consuming, but we just chip away at it. We do it a little bit at a time. Okay, so that's what your quiz is going to cover. That should help you out. Go back and study if you need to, and if you have specific questions and you've already tried to look through videos and stuff, shoot me an email and we can see if we can get you sorted out. Thanks for watching, and good luck on your quiz.